My name is Todd Coleman. I'm the archivist at Burton Snowboards, and today we are here in Burlington, Vermont at the headquarters, and we're outside of the Craig Kelly prototype facility, and it's great to have you guys here. Just to give you some background on who Craig Kelly was, he was a 4-time world champion, 4-time US Open winner, and a 3-time Mount Baker Bank Slalom champion. At the height of his competition career, kind of walked away from competing and went on to free ride. And another thing besides Craig's legendary riding was he had an engineering background. He was really good at relaying feedback, working with the engineers, working on new ideas for boards, boots, bindings, even jackets and pants. And this is really where the whole rider feedback started with our company, and it's really important to us. You know, we have testers all over the world. We have, of course, the team riders all over the world as well. Unfortunately, Craig passed away in an avalanche in 2003, but Jake Burton wanted to name this building in memory of Craig and all he did for snowboarding and for Burton. So this is our rapid prototype machine lab, and this is our 3D printer. It's our object printer, and what it does, it takes semi-melted UV curable plastic and prints it at 0.004 of an inch thickness. So it's capable of up to 18 different diameters of stiffness. Basically, the product managers, the engineers next door are working 2 years ahead of the product life cycle. So right now in the stores you see 2014, and they're working on 2016 and beyond. So let's say we're working on a new boot outsole or something for 2016. They're working in SolidWorks. They have a CAD drawing. They send it over to John over here, and John's our mastermind behind this zone, and he can print up the object for them, and it'll actually switch out the stiffness of material from softer to stiffer to softer. And you can see it's working right now. It just goes across, switching the materials, and then the UV light is curing that layer and just continuing it, just like a printer. This allows us to ID the product and see if that's the direction we'd like to continue to go towards production. Another machine I'd love to show you is over here, our Sls Machine. And this is really my favorite because we can actually ride the parts that come out of this build. So what happens is you'll notice there's 3 tubs in here. So there's one tub here, one tub here, and one tub here. We start off with, we fill up the 2 outer tubs with a nylon 11 or a nylon 12. It's a plastic powder. And this tray comes up to the top, so the tray starts out level here. We shut this hood down, and the whole zone heats up to 10 degrees below the melting point of the material. Then this little roller here will spread the powder across the center at 0.005 of an inch thickness. So it's really, really thin. And then this 100-watt laser up here will sinter the part, cause this part to bond together, and then the center tray will drop down 0.004 of an inch. A new layer of powder will come across the center and then create that part, next layer. So what we're doing is it's almost like when you picture a loaf of bread being made one slice at a time. It's called additive manufacturing. If you look closely on this high back that we made in here, you'll be able to see the lines here. So at the end of the build, all the powder and the parts are in the center. And it's kind of looks like that game Tetris. You got all the parts stacked in here to utilize the build, except for the parts cannot touch each other. And then what we do is we bring that center block out, and let's go to the breakout room back here, and I'll show you what it looks like back here. John, you want to join us? That'd be awesome.
So basically, the powder's coming out of the machine in a cube. We pull the cube off, and then sort of just dig through and find parts. So this is a Tensile Bar, which is the part we use to test the materials and the builds. Once we pull it out of here, we'll move right over here. It's just a glass media to clean off the excess powder. So then you have a Tensile Bar part that we can test in our lab. Make sure that our parts that are in the machine that possibly are going to go on snow are safe.
So it's basically like the sky's the limit. These machines started off in more like military and NASA type operations, and like the turnaround time is so much faster than outsourcing your prototypes. It might take weeks to get it back, and then if you tweak it and then ship it again, next thing you know, you got months and months, where this is days. You know, we can do the SLS machine, we can do anywhere from maybe like 12 to 24 hours, depending on how much product we're growing. And the 3D printer could be, I don't know, 4 to 8 hours, just depending on what type of part we're building. So this is the machine shop, and this is where Norm and Mike St. Orange work, and these guys keep all the machines in the building up and running, and they also help customize machinery to help us in the manufacturing process. So you could say we not only build snowboards, but we build machinery as well. This machine, her nickname is Wilma. She cuts out the molds for us. So there's a bunch of different drills on there that they can switch out, and this, what we do is we create a mold here that is the first step in making a board. There's so many different molds, like for example, say the custom, the 158 versus the 162 is a different mold. So we're now in the parts department, and let me show you a couple examples of our wooden cores. So this is our Dragonfly core, and over 500 different parts make up this core. Another example would be our Superfly 2 core. It's pretty cool to see the amount of detail that goes into a core, the amount of time and engineering that goes into just the core. You know, you don't get to see that in the board, but it's so important. So once we know, which model we're gonna make, we'll take the core and we'd bring it over to this green monster over here, our CNC machine. So Mike St. Orange would put it down here, and then he would have everything, all the input here, and this arm would come across and actually cut out the shape of the board as well as the channel zone. This is actually Hannah's board that we're making, but at this point, the CNC machine cut out the shape and the channel zone here, and you can see this is our sidewall. So we have a lot of different colors over there that we can choose for our sidewall. It's a plastic material that we'll cut really thin, and we'll glue it to our core at this point because we want to profile it with the core. So from here, we fire up this machine, and this is a big belt sander that goes up and down. And this is how we really hone in the profile of the board. So we'll go from one even thickness to down to about 1 millimeter in the nose and tail. This is where we add squeeze box, a subtle wave throughout the board, and really get the board to flex where we want it to flex this way. After sending it through here one time, we bring it over to this table behind us, where we're able to have this arm come across and do incremental measurements and record the thickness of the core here into a spreadsheet, which then calculates how much more needs to come off the board. It'd be like something like that. Calculates how much more the sander needs to take off to be within spec. Spec is 0.2 of a millimeter, so like one of our hairs here. And then we shoot it back through the second time to pretty much be perfect. So then when all the parts are ready, we'll go back out to what we call layup and show you how it all comes together. Grant here is going to be putting together a board for us. This is going to be a Sean White board. And just to mention, it's the same process as production. So this is actually a prototype board, but same process as production. It's all hands-on. So Grant's getting the resin all set. It's a 2-part epoxy. Mixes the resin with the curing agent. So I'm gonna spread out the resin. You can see the base material, the PTEX material, is already laid into the mold. The metal edge is in place. The strings there is a gummy material that's pretty much an industry standard. You'll see all the companies use that. That's what helps keep everything together, the bond between different materials, the metal to the fiberglass to the different plastics. So now we're gonna be doing some fiberglass. You can see the black strands through the center we call carbon I-beams. And carbon is a nice and lightweight material that adds pop to the board. He has probably roughly between 10 and 15 minutes before that resin will actually harden. You can see it's you know, it really is a hands-on whole process where it really comes down to craftsmanship. These guys make it look so easy, but it's actually not too easy to do. The core is the meat of the board, so to speak. It's we call it sandwich construction. So this would be like the lettuce of the sandwich, the fiberglass. So we put a top sheet of aluminum on here just to seal up the mold. And then we're going to be jumping over to the press, which are essentially our ovens. Place the board inside. You notice the board right now is flat, and now it's going to take shape. It heats up between 80 and 90 degrees Celsius. It'll stay in here for 13 minutes. The last minute and a half will run cooler water through here so that it's not scorching hot when they open it up. One interesting thing too is how we get our bends. So nowadays, you know, boards will have a lot of different bends. Well, you can see this is camber because it's high in the center here. If we were going to do V-rocker or flying V, we could lower that, or you can do any kind of bend you'd like by adjusting these bars underneath. Well, thanks for stopping by today. It was really fun to show you around our Craig Kelly prototype facility. We're lucky to have the 10,000 square foot facility solely devoted to research and design, and have the ability to think of new ideas and bring them life as quick as a day to get a rider on a whole new setup. We can do a board as quick as 2.5 hours. So we feel fortunate to have that and just make the evolution and the process more seamless. So thanks for stopping by.